Welcome, everybody. I really do appreciate you joining us here today. I'm going to be moderating today's discussion. To give you an overview of what this webinar is going to be about, it's specifically about this keep nut insert made by Special Insert. We're going to go over the materials these anchors will work in, your different applications, how the keep nuts compare to other anchors that are similar, and we'll culminate everything with a live demo with the Special Insert team in Italy as well. So joining the presentation will be that team from Italy. I'd like to welcome our rep, Giovanni Spandre. Giovanni, how you doing today?
Oh, looks like we don't have sound for you, Giovanni. Maybe check your.
I'm gonna check that mic.
Hello, everybody.
There we go.
Okay, hello. Thank you for attending our webinar as a guest from 5 continents around the world. We are very honored about. Let me introduce my colleague, Mr. Andrea Sanua.
Hi, good morning.
Head of Research and Development at Special Insert, and Mr. Andrea Dellino.
Hi to everybody.
From Technical Department that will perform the live demonstration.
Thanks,
hello,
guys.
See you later. Thank you.
Great. Appreciate that, guys. And leading our presentation here will be the National Sales Manager here at Chemical Concepts, Andrew Morris. Andrew, how's it going?
Oh, it's going great. Welcome, everybody.
All right. So before we get into it, I just do want to let everybody know I will be monitoring and our team will be monitoring the Q&A section. So feel free to drop any questions in there. You'll find that in the Zoom meeting box. We're also monitoring the chat box. So if you drop a question there or the Q&A box, we'll keep an eye on it and answer them either during the presentation or after. And I do want to be clear, we will be sending a recording of this video to everyone post presentation. So you should get that within 24 hours and we'll make sure you can hold on to this for future use. So with all that being said, Andrew, feel free to lead the way, man.
Thanks, John. So welcome, everyone. Today's discussion is about the keep nut anchoring system. So if you're a stone fabricator that is looking for a better way to mount sinks in materials of different thicknesses, or perhaps you're a facade engineer looking for a better alternative to undercut anchors, our goal is to give you a good overall picture of the system, how to use it, how it performs. And by the end, I think you'll walk away with a better concept of what these fasteners can do and whether or not they might be a good fit for some of the projects you have coming up in the future. So for an agenda, we're going to start off with an overview of the basics, then followed by the live demonstration from Italy, which I'm very excited about. And then we're going to cover some of the testing data, talk about some of the advantages compared to other systems out there. And then we're going to go through some applications and case studies to give you some ideas about how these are used. Then we'll wrap up with the Q&A and we'll leave plenty of time for your questions. There is a brief survey at the end, so please take a minute to fill that out. We'd love to hear your feedback. And at the end, if you're ready to get started with Keep Nuts, we are offering a promotional deal for attendees as a thank you for joining us today. That's if you're in North America. So if that sounds interesting to you, be sure to look out for a follow-up email after the event for details. Before we dive in, I just want to give you a very brief background on Chemical Concepts. If you're not familiar with us, we are product assembly people. So manufacturers and engineers of all kinds come to us when they have got design challenges or applications where traditional fastening methods can't be used. Perhaps they're looking for process improvements. Whatever the case may be, we provide solutions involving adhesives, sealants, tapes, and specialty fasteners. And we have a great team of subject matter experts to kind of make recommendations and help you in those efforts. We are active in various industries, including stone and solid surface fabrication, transportation, cladding facades, signage, composites, and everything in between. We are located in the Philadelphia area. You can see on the screen here that we've been around a long time, coming up on 60 years, and we are the master distributor for Special Insert in North America. And now Giovanni is going to tell you a little bit about Special Insert. Giovanni?
Hello, Special Insert is an Italian company specialized in engineering, distributing and trading of industrial fasteners. Since 1974, Special Insert manufactures a wide range of products such as tubular threaded insert, bushes for plastic materials, salt stud, and self-clinching stud. Our main target is to meet the customer needs, offering them in advance and high quality products and the possibility to produce non-standard items. The company counts on an in-house research and development department that is constantly developing new fastener solutions for different applications. So far, Specialinsert developed and owns 5 international patents and 5 international registered trademarks. The sales organization supports the Italian market and worldwide market, thanks also to our distributor network. Today, Specialinsert exported in 82 foreign countries around the world. Thank you, Andrew.
Yes. So what is a keep nut? So a keep nut is a really unique mechanical fastener that relies on layers of elastic metal teeth or crowns. Because of this unique design, the keep nut is able to securely anchor into hard materials using just a normal cylindrical hole. And that's what's so interesting about it. Unlike other fasteners that either have to expand, which can create a lot of tension in the material, or other fasteners that require a T-slot or an undercut hole, maybe some fasteners rely on epoxies in order to work. The keep nut is totally mechanical and surprisingly simple. Keep nuts are made of stainless steel and nylon, and they do come in a variety of sizes and configurations. The keep nuts were designed to be used on porcelain and natural stone for ventilated facades, but some other common applications include other vertical applications in wall coverings, signage, decor, and other interior parts, furniture. Tabletops are really common, as is armrests and other parts that are involved in furniture. As you can see on the screen here, the keep nuts do work in a wide variety of materials. The thing to keep in mind is that the keep nut is best suited for very hard and dense materials. So I'd not recommend the keep nut for soft plastics such as cellular PVC, soft woods, but the keep nut does work very well in natural stone, sintered materials, porcelains. You can see there's other products such as composites, plastics, phenolic core products such as Trespa, ultra high performance concrete, and even solid metal sheets if they're 8 millimeters thick or more. So how do you install a keep nut? So the first step is to drill a straight cylindrical hole using the correct size drill bit. The keep nuts do come in different sizes, but the diameter of the hole is always consistent. So you're looking for an 11.8 millimeter hole, and we'll talk about the drilling methods in a minute. Next, you'll use a very simplistic hole testing tool. We call this the go, no-go gauge. You'll see this on the live demonstration as well, but one side says go, the other side says no-go. If the no-go side fits in the hole, then the hole came out too big. There's also depth markings on the side for the most commonly available sizes. Next, there's a setting tool, and this is just a plastic rod that has a threaded rod on the end, and you just simply thread the keep nut onto the tool, punch it into the hole with a rubber mallet. At this point, the insert is ready for use. As for drilling methods, the keep nut works great with automated drilling methods, and that's usually preferred. If you're a stone or masonry type of material that you're working with that requires wet drilling, you can use a CNC router for stone. If you're using solid surface, HPL, or materials that fabricate more like wood, you can use CNC routers intended for wood and plastics. In this case, most often I see people using small router bits, say 1/4 inch, and then they program the machine to drill in a spiral to end up with a hole that's the correct depth and diameter. With wet drilling, diamond bits are usually only designed to go up and down. So you want to use the correct size hole. We sell 11.8 millimeter drill bits, and they're relatively inexpensive. They're around $40 depending on what quantity that you buy, and you can get hundreds or even thousands of holes out of one bit depending on what material you're using and what your setup is. If you're looking to use a manual tool, there are options as well. Solid surface, HPL, and other materials, you can simply use a lithium-ion drill with the correct size drill bit. We also have depth stops available, so you can drill repeatable holes very easily. If you're working with materials that require wet drilling, we do have the KDM series drilling machines. These have a vacuum foot that holds the drill at a perfect 90 degrees. It can suction down to even the rough side of the stone, and it can drill a hole in granite in 10 to 15 seconds. We're also working on an electric version of the machine, which will be great for drilling in the field, but that will not be available for the next several months. So at this point, we're going to stop for a minute and show you this brief video, which I think will give you a better picture of what I've just described. So let's watch. Excellent. So hopefully the audio came through with that. All right, so why choose keep nuts? Well, first is speed and simplicity. So for installation, the keep nut just requires a simple blind straight hole. The hole does have to be accurate though. It's also possible to drill on site with the right equipment, and depending on the materials, this can be very easy. It is also easy to verify that the holes are drilled correctly. The inserts are installed using only pressure, so there's no need to let the material dry off, mix up epoxies, move the material to another area. All you need is a mallet and a setting tool. The keep nut is one of the fastest systems out there, especially for blind anchoring, and especially with automated drilling. So if your drilling process is 2 to 3 times faster, that's like having a whole second machine. So we've had many of our biggest customers do their own cost studies, and in every case they come back and said that the time and labor savings were really significant. Another reason is the versatility. Here you can see the most common sizes and varieties of keep nuts, starting with the smallest to the largest. You have the 1 crown version for your thinnest materials. The thinnest panel we can do at this point is 8 millimeters in thickness. The 2 crown is far and away the most popular size. This version is best suited for undermount sink applications, 12 millimeter materials and above. Then you move up to the 4 crown types if you've got heavier duty applications. This is recommended for cladding or vertical surfaces where you have 2 cm or 3 cm granite, or if you need higher strength for softer materials such as soft marbles and high performance concrete, which is typically softer than stone materials. In stone fabrication, it's not uncommon to do 3 cm granite on Monday, 2 cm marble on Tuesday, 12 millimeter porcelain on Wednesday, and 8 millimeter Decton on Friday. So from a quality and process control standpoint, it's hard to have 5 different systems for 5 different materials. Here you can have 1 product and 1 process that works with a lot of different surfaces. Next is safety and security. So in Europe and many other countries that use the standard, the keep nut has ETA and CE certification for porcelain. We also just received, which we're also very excited about, the test results for the ASTM standards for North America. This was performed by the lab at the Natural Stone Institute. So we now have ASTM tests for different types of stones. We did a hard stone, a soft stone, a medium stone. You'll see those results in a couple slides. We have several porcelain materials, including sapien stone, and we're working with other surface manufacturers such as Cosentino and Lapitec and others in order to get even more test results on more materials. The keep nuts, as we mentioned, are stainless steel, so they're suitable for interior and exterior applications. They're also fireproof. The 1 plastic component is self-extinguishing, and once it's installed, it does not affect the performance or the strength of the fastener. It's also a totally mechanical system, so there are no variables in terms of proper mixing of the adhesive or whether or not you get good adhesion or the adhesive performed correctly. And lastly, the keep nut is designed with a stop at the end, so it is not possible to over-thread the keep nut. I've heard of issues with other systems that if you over-tighten the bolt can keep moving and you can actually crack the whole panel if the bolt goes too far. With the keep nut, the bolt will just spin if it's over-tightened, so this kind of failure is not possible. The keep nut is also flexible and easy to work with after installation. When using the flush mount, there's nothing sticking out above the surface, which is great for storage and transportation. The fact that it's flush opens up possibilities for using any type of hardware or bracket. Other anchors require a specialized bracket that is required to accept the part of the anchor that stands off from the material. But with the keep nuts, whether it's a hardware or a hinge or a bracket or a clip, the possibilities are endless there. Now, if you look at the photos, you can see what your options are in terms of what kind of actual fastener you use to attach your hardware. So if you look at option B, you can use a machine screw with a head on it. But the problem is that the screw has to be the exact right length. And so you might be limited by what lengths are available. This is why option A is usually what's recommended. In this case, you use a threaded rod, and that rod could be whatever length that you need, and then a separate hex nut. That way, you're guaranteed to use the entire usable length of the threads of the keep nut itself, and then the hex nut can just be adjusted to accommodate whatever the thickness of the hardware that you're using, and you don't need different hardware. You don't need different screws for different thicknesses of hardware. And that brings us to the live demonstration, which is streaming to you directly from Turin, Italy. Take it away, Giovanni. And let me just move the camera over. Here we go. Giovanni, you're muted again, just to let you know. You're still muted on the, there you go.
Hello, everybody again. Now we will do all the tests and all the steps we need to perfectly install a keep nut. The first step is the drilling. Put the material under the drilling machine, and we have an adjustment to adjust the depth of the hole according to the keep nut model. Now we perform a simply cylindrical blind hole. Now, once the hole is done, we check it with the go, no-go gauge. First, we put the no-go side and be sure that cannot enter the hole. Then we go on the go side and we check that it can go in up to the indicated level according to the keep nut model. In this case, is the H8.5. When everything is correct, we will fix the keep nut under the punch and hammer it into the hole. That's all. Now the keep nut is installed and we can go to fix it in our structure. In this case, it's a system for facade that we apply with the grub. We simply screw it in, put washer and spacer, and the nut, and just tighten it. And our tile is ready for the installation. In the substructure, for instance, of a cladding facade in this example. And that's all. The work is done. Now we will perform a pull-out test on a samples of keep nut installed in a marble. We fix it in the pull-out test machine. Please be aware that the result is displayed in kilogram force that are equivalent to 2.2 pounds. It goes closer to 600 kilos.
Wow.
That's pretty good. We can say that the result is definitely appreciable. Okay, that's all for the lab. We can come back to the presentation.
Do we have any questions on there while we have the lab? If anyone wanted to see something specific? I don't know if we have time for that. Let's see if anything in the QA. Okay, we'll move on. So here, let me move this spotlight. All right, whenever you're ready, Giovanni.
Okay.
Can everybody see the screen now? Yep, here we got it.
Okay. So next slide resumes some tensile pull-out strength value we reach in our laboratories for a variety of material, and as you can see, are all very impressive values. You can see, for example, in granite or in HPL, we go over 1,000 pounds. In the next slide, we have the same kind of result obtained on the National Stone Institute attending the test for the ASTM. As you can see, you have the tensile and shear test resumed according to ASTM test. And you can evaluate it because you will receive this presentation after this meeting, so you can see all the value for every different material. So let's talk now about the competitors analysis. Talking about fixing system in mechanical way in the stony material, our competitors are all working with undercut. Undercut means that you have to make a very complex drilling process. You need specific drilling tools. You need a specific oil check tools that most of the case is very tricky to use. And you have to make the installation of the fastener before ship the tiles to the workplace, because they are also working with an external dimension that can give you many difficulties during the packaging of this item, especially if you have to ship it very far from your workshop. Okay, Andrew. So talking about the undercut process, we have, first of all, the need of a specific drilling machine with an eccentrical rotative axle. Then you have a very expensive drill bit that costs from 6 to 10 times more than a standard cylindrical diamond drill bit. Then the drilling time is very long. Average is twice time more long than standard cylindrical hole. Then it's also very difficult to do this process on site directly. And it's necessary to screw those inserts before the shipment of the parts. Before, otherwise, if you just insert it, they get loose under the transportation process. One added value that we have is that we can customize our product according to the customer needs. You can see a few examples we have made. For instance, we can have it like a stud, not with the female trade, but with male trade for a specific application, or we can produce specific length according to the customer specification. The last one you see on the right side, the H29, was specifically developed for a stone material called Wracław, and we get 1 kilograms or 1 tons of pull-out force as a result of this insert put it in this stone. Now we just want to give you a short overview on on a portfolio of the most significant application we have made recently, just to give you a roughly idea of how is used and appreciate our product in this industry. The first of all one is the Gateway Arch in St. Louis, United States, where during the renewal of this monument, very important in the US, the cladding was done thanks to our KeepNut. Then we have a very recent one, the building called Square in Gdynia, Poland, done with KeepNut with material Lapitec. We have the Azerbaijan Diplomatic Academy in Baku that is also using H15 on KeepNut on natural stone. The Moscow International Business Center, and the Moscow's VTB Arena Park, when we deliver almost 1 million KeepNut in H15 length to do all this project. The Sheikh Abdullah Al Salem Cultural Center in Kuwait, a private residence Al Fanar in Saudi Arabia, and the most recent Quatur project in Belgium, with credit to our good customer Okeanos Group. One of the most biggest market for KeepNut is anyway the undermount sink on the countertops. As you can see, 4 KeepNut with very easy installation directly on the wet stone under the CNC machine work. We can hold a people inside the sink without any problem, either if the people is of a very big dimension. Then we have other application in the kitchens that are made by a company Lapitec in countertop and also in drawer front, when the hinges of the kitchen are fixed with KeepNut as well. Then we have many other application that is for decorative application or for work table, for laboratory table, bins, desk for home, desk for public restaurant, bars, and similar. And we can find every day new application for this product. In this section, you can find some video that can give you a good idea of how our system works in the cladding facade installed in stone or solid surface. And you can as well download the general catalog and data sheet of singular part. If you can, we will be very happy if you follow us on LinkedIn or an Instagram.
All right, thanks, Giovanni. So at this point, we've covered most of the basics on the KeepNut. If you'd like to learn more, or you think this product would be a good fit for some of your applications, please reach out to us after the event. I know, as we mentioned, that we have attendees here today from all over the world. When I checked this morning, I saw signups from Brussels, Dubai, Istanbul, Paris. So for inquiries outside of North America, I would direct you to Specialinsert. Their contact information is on the screen. I have it for Giovanni, as well as their main office. They can direct you to a local distributor if there is one. They've got many distributors in many countries, and if not, they can help you directly. For inquiries within North America, you can contact Chemical Concepts. I have my contact information as well as our main office number and our website, etc. So myself or other members of my team will try to assist you right away if you get in touch with us. If you're wondering where you can purchase KeepNuts in North America, they are available from several distributors, including Braxton Bragg and Grant Quartz. You can also purchase keep nuts directly from Chemical Concepts. As I mentioned earlier, we do have a special promotion on keep nut starter kits, which is for customers in North America and for those who have attended the webinar. So look out for a follow-up email that will be sent in the next 24 hours. This will be, as was probably mentioned, you're going to get a PDF copy of this slide that you're seeing now and the whole slideshow and an on-demand recording of the whole event. So if you want to share it with anyone else in your organization, all the links will work as well. So on the PDF copy, so don't feel like you have to write down all this contact information, but in case you wanted to, I wanted to leave that on the screen for a second. So before we get into the Q&A, I did want to mention what other products and solutions we offer in case we can help you with anything else. Something I did want to mention today was another anchoring system if you're working with honeycomb composite materials. Lightweight stone panels have a lot of advantages, but it is difficult to attach things to a hollow core. So this is a product called the Deform Nut that's also manufactured by Special Insert. We don't have time to go over this in detail, but maybe that's a subject for another webinar. But do contact us if you have if you need a solution to mount honeycomb panels. People also know us for our adhesives, sealants. We sell a lot of silicones, tapes. So if you're in the countertop industry, you might know our counterbalance line of support brackets. But bottom line is, if you're having any challenges involving adhesive, sealants, or these other products, we'd be happy to have a conversation, see if we can point you in the right direction. So with that, I will pass that over to John to kick off the Q&A.
Thank you so much, Andrew, and thank you, Giovanni. Hope everyone learned a little bit more about this insert and the capabilities it has to offer. So with that, I do want to get into the Q&A section. We have a nice number of questions already asked, so feel free to drop any questions in the Q&A box or in the chat box, and we'll make sure to get to them. Andrew, I'll start off with you. I got one here from Jorge. He asked, what is the minimum thickness required on the material to be installed?
Yeah, so on the smallest keep nut, which is the 1 crown keep nut, that has a depth. Well, there's actually 2 types of 1 crown keep nut. Maybe I'll see if I can pull up the picture. There's the flush mounted and the kind with the flange. The 1 crown with the flange, which is the IM1T model, that has the smallest drilling depth. So that is drilled to a depth of 4.5 millimeters. And so generally it's kind of on the subject of the installer in terms of, what they feel comfortable with, how much thickness, what percentage of the material they want to drill into. We say that, basically an 8 millimeter panel is about the smallest that normally we would recommend. If you have a panel that's shorter than that and that's thinner than that and you're comfortable drilling in 4.5 millimeters, then it will certainly work. Hopefully that. Anything you wanted to add to that, Giovanni? I see you're still muted on the Zoom, but if you wanted to have any comments.
Here we are.
So anything to add to the thickness question?
No, it's perfect. You have studied very well all our information. We are very proud of you.
Thank you. I appreciate that. We do have Bogomil, who mentioned that he has they're the distributor in Poland. If anyone is in the area of Poland, it's Mokujemi, and he's mentioning that he does have some customers that do use the IM1T model on 6 millimeter product, HPL and solid surface. So thanks for that comment, Bogomil. I happen to see that in the chat. But sorry, go ahead, John.
Great. We have another question here from Raphael. He mentioned that they produce a lot of porcelain tops, 1/2 inch from Porcelanosa. He said that they do not recommend a drill on it because it creates tension points on the slabs that can cause cracks. Have we had experience with this type of material, and what is the depth and how do we go about that?
May I answer to this question?
Go for it.
So this is a very good question that allowed us to explain that for porcelain, we have ATA certification. That means that European certification office have made all the possible tests on our keep nut on those material. If they use the IM for instance, 2S, M6, H6 on half inches, they will absolutely have any problem, and it will not create any kind of tension inside the material. If those people will be interested, we can send them the ATA certification where all is explained in detail about it.
Yeah, and I know we have some people from Porcelanosa on this call. So obviously, every manufacturer is going to have their own recommendations on what they do with their material. We'd be happy to discuss with any of their technical people whether there's any modification that is possible for their technical recommendations and whatever. But we'd be happy to do whatever testing is needed to be done to satisfy everybody. But I just want to point out that I can't speak to Porcelanosa's product in particular, but we have done quite a lot of testing on 12 millimeter porcelain products. You can see this. I want to bring up this picture here. This is actually 12 millimeter porcelain, and you can see that we did this at a workshop in Nashville, and you can actually see you got two people standing in the sinks. And I want to point out too that that's each of those sinks is only supported by 4 keep nuts. And then silicone we didn't have time before constructing this to even add silicone. So there's no sealant of any kind. It's just the anchors are the only thing. I know someone might look at that and go, oh, the silicone sealant does 90% of the work anyway. There's no silicone in this joint, and it held up fine. So I would say 12 millimeter porcelain in general is a great application. And we haven't had any issues to speak of with parts cracking or breaking. The only thing I would say is on your when it's drilling, we do recommend, number one, to use a correct bit. So there are bits with softer bonds for porcelain. So we have 2 bits. We've got and this is a good thing to kind of bring up. It's a granite and quartz bit, and then we have a porcelain and sintered stone material bit. So you want to make sure you're using the right bit that'll give you the maximum life out of your bit. And then also you might want to back off on the feed rate if you're doing automatic drilling. If there's too much downforce, while the drilling, it's a little bit harder to drill porcelain materials, then you can crack the material. But assuming that your machine is set up correctly and you do some tests, I always recommend doing things on scrap pieces. If you're doing something for the first time, I'm sure you'll be able to find a setting that will work okay.
Thanks, Andrew. Got another question here from Jorge. He said to clarify the dented outer ring. So I'm assuming the crowns or the teeth of the keep nut and how they expand to stay secured in that drilled hole.
Giovanni, did you want to field that one?
Yeah. The keep nut crown are made of elastic spring steel. It means they flex only in one direction. That is the one that allows them to go inside the material, but doesn't move in the other one. So when you apply a force, they go under tension and they will anchor to the material.
Yeah. So the analogy that I like to make is if you're familiar with like the children's toy, it's like a Chinese finger trap where you put your finger into the device, and as you try and pull your finger out, it's almost tightening on your finger. That's kind of how it works. And I did want to clarify the question said, how do those teeth expand? So that's one of the nice things about it is they don't really expand. The hole is slightly undersized, so the teeth actually compress slightly as they're put in. And what that means is that you end up with a low stress anchor where it's not really when the system is at rest, it's not really applying stress onto the material. So great question.
I have another question here for you. This is a good one. Are your products certified to be used in hurricane prone areas like Florida and the Gulf Coast?
We don't, there's the Miami-Dade certifications. I don't believe, typically it's the installers that would do the test for a particular project to make sure that it's certified for wherever it's going to be. I'm not aware of any projects that are done in the Miami-Dade area for hurricanes. I know we did do some testing on the deformed nut for the projectile test, which I know that involves. I have no reason to believe that it wouldn't pass, but I think those are tests we probably have to do if a project arrives. I did want to also mention that, this is still a newer product in the cladding facade market for North America. It does have a very good track record, in Europe and the rest of the world. And so we're just now trying to kind of recreate a lot of the success that we've had in Europe and the rest of the world. That's why we just got these test results from the ASTM, from an independent lab. So we're trying to basically do some of that development work now. So that's something that we'd be happy to talk to you about if you have projects that are in Florida or in areas where they need those certifications. We can work through that.
Great. Thanks, Andrew. Got a question here from Mateo. Do we have any numbers on the pullout value on 10 millimeter and 12 millimeter porcelain? Was that in that
we do. I'll see if I can navigate to that slide. There's more than what I'm going to have on the tip of my fingertips is the numbers that we just got from the Natural Stone Institute. Here, let me where those testing numbers. But we've done many more testing on porcelain materials, but this is just what I have in this presentation. So here's 12 millimeter porcelain. You'll see in shear, we have 1,670 pounds in shear strength, and that's average. And then in tensile, we have 614 pounds for 12 millimeter porcelain. We have some other porcelains that we've tested. We also have the ETA certification. The full report has testing on tensile, shear, combination of tensile and shear, and so we've got additional porcelain numbers. I'll see if I can put our friends in Italy on the spot. I don't know what other information they have at their fingertips. So Giovanni, do you have any additional numbers handy on 12 millimeter porcelain?
No, it's these numbers are more than correct. Yes.
Yeah, so that should give you an idea. And then if there's any more tests, we can, you feel free to email us whatever. We can send you some additional test reports if there's more data that you'd like to see.
Sorry, Andrew, if you can stay on this slide, we can directly answer to the next question that is from our friend John Grossworth. Is talking about the result on UHPC. And as you can see, the last four value on this slide are especially talking about UHPC 15 millimeter and 19 millimeter with the correspondent tensile value and shear value.
Yep. And the only thing I would add to that is typically for UHCP, they are a bit softer than like stone or porcelain. So you normally, to get those values, you normally have to go to the next size up keep nut than we would normally recommend, for stone, because it's kind of the harder the material, basically the higher pullout strengths that we get. So if you look at the granite, for instance, I was really just shocked. Actually, we just got these numbers earlier this week. That the black, for those of you that are granite and solid surface fabricators, it probably would come no surprise to you of how much harder black absolute granite is compared to other types of granite. But here on the black absolute with the 15 millimeter keep nut, we got 3,300 pounds in shear. That's the biggest number I've seen for anything with the keep nut, at least with that size keep nut. So as the harder, and then you see on the softer stones, the numbers go down a little bit. So on a UHCP product, I would typically start with the 4 crown with either the 8 millimeter or the 15 millimeter, whereas with a stone kind of or a harder material, you could probably go with the 2 crown, which I said is our most popular. So I just wanted great question.
Got a great question here from Prakash. He's asking, can we reuse the keep nut if the stone is broke or for some other reason? No, we wouldn't recommend reusing a keep nut. Those crowns do get, kind of deformed as they're inserted into the stone. And, depending on what you're doing, if it's furniture, maybe the risk is low, but if it's something vertical, for whatever it costs for one keep nut, I think you'd be better off using a new one rather than risk something coming apart and falling on you. I think any money you'd save by trying to reuse a keep nut, you'd probably
lose in either lost sleep or having to go back and fix something. So I would certainly recommend a new keep nut for any hole that you try and drill.
Thanks, Andrew. Another question here from Kurt. He said, is there any values we have for tensile or shear when installed in steel?
Yes, we have done some application also on steel, on carbon fiber, on fiber resin, many different material. Steel is very general. It depends how does it mean steel. If it is milled steel, if it is like a tube, if it is drilled by machinery, if it is stainless steel, we can have a big variety of different results on this. If you would like to address us the specific of the application, we will be performing a test for you and give you the result so you can evaluate the exact performance you can obtain.
Yeah, and I think we do have, we were sending out invitations for this webinar to all sorts of industries. We did send it out to some sign manufacturers. So I don't know if anyone joining us today is a sign fabricator. There's not maybe as many applications for sign fabricators, but I've talked to many sign fabricators who want to use it on metal that's, half-inch thick or quarter-inch thick, where they want to use it on small letters. Where they don't want to weld and have something that's visible on the other side. So there are some interesting applications for signage where you could use them in metal. So yeah, I think that's a good application. There's certainly lots of different types of fasteners for metal, but in some special cases, the keep nut could make sense.
Here's a question for you. What is a facade?
Yeah, so we have people that are doing, a lot of the people that are joining us are people that are facade manufacturers. So we talk about the building exteriors or cladding. So people are putting, external facades on the types of buildings and to have these decorative looks, they might want, you might see buildings with natural stone exteriors or, that are cladded in porcelain or cladded in a wide variety of materials. One thing that the keep nut is often used in is ventilated facades, or what they call ventilated facades, which is there's a kind of an air. I'm not a facade expert. I do understand the fasteners, but basically there's an air gap between the building, and there's I've spoken to a lot of facade engineers that they talk about the advantages in terms of insulation and water performance by having an air gap so that water can't penetrate the facade. If water does penetrate the facade, it doesn't go into the building. It just goes into the air cavity between the. So those are typically installed with rails. And so if you saw actually a great example would be if Giovanni, I don't know if you can move the camera and show the facade example that you have in your showroom there.
Yes, wait a second.
But you can see we saw they're typically used with clip and rail systems. So if you're a granite fabricator and you put stone up and you're not familiar with some of these clip and rail systems that are out there, you could see some examples here. So here, let me spotlight this video here so everybody can see this.
Okay, now it is connected. We have two different kind of facade substructure produced by customer of us. One is done with vertical structure. When you fix, as you can see from this Lexan panel, you can see through how it's made the fastening to the main rail. And we can see on the other side an horizontal version. Made with horizontal rail. Andrea, in basso c'è, se vuoi inquadrare lì la piastrella dietro come è fatto.
Yeah, so this is the deform nuts then?
With a different kind of fastening to the rail. This is a lightweight stone with honeycomb on the back, but fixed with keep nut as well. We have a keep nut according to this thickness that goes through the honeycomb and gets anchoring in the stone.
Right. So we have two solutions there. In this example, I know some like local regulations, they want the mechanical fastener into the stone. So even though there's a honeycomb backer, they still want to be able to go into the stone.
Yeah. You see, this is how it looks like if you go in the section of this application.
Right. Or if you're using lightweight stone, with a lot of the lightweight stone panels that have honeycomb in the back have very thin stone where you couldn't use a keep nut. In that case, we have the deform nut, which actually anchors into the honeycomb itself. So
Correctly.
two options for you depending on your application. So here you can see how the clips are actually installed. And again, some anchor manufacturers will have specialized clips that have to be used with their system. Once you have that female thread on the panel, you can put any clip or any piece of hardware you want. So if there's a particular manufacturer of clips and rails that you like to use, you can use whatever you'd like there.
Our system is open to accept every kind of subtractor. We have definitely no problem on that.
Yep, and that was a great example of how they're installed. They're usually these extrusions, they're extruded metal, and they're designed to just kind of fit right onto each other to make it very easy to remove panels. A lot of people that do facades, they might be used to using, if they're not used to using undercut anchors, they might be used to using anchors that go into the side of the stone or that go into the, that kind of stack, and they're called kerf anchors. So in those, if you have a panel that breaks in the middle, you can't replace it. Where if you go with a back anchor like this, you can remove one panel if possible.
Sorry, Andrew, to interrupt
No
you, just to show that all this, the side of the facade in the corner is made by porcelain. Our friends before was asking us about keep nut in porcelain.
Right.
You can see from this style that is a typical application made on porcelain tile. Okay.
Great. Thank you, Ryan, for that question. I got a couple questions here. It looks like G, I'm sorry, G, I don't have your full name here, but they're asking about how can customers calculate the number of keep nuts required depending on the application?
Well, I'll take a stab at that. So we always encourage, while we can give you a lot of support in terms of how you use the keep nut and can talk to you about your process, we generally do like to see engineers being involved in projects. So in the projects that I've worked on, typically the engineer kind of really makes the recommendation. I'll shout out to a specific, I don't know if there's anyone from Pico Engineering on this call, but we've done several projects with Pico Engineering, and they kind of specialize in stone projects here in Canada and North America. And there's lots of other engineering firms that are out there. That's one that just kind of jumped right in the forefront of my mind. But we could, if you need a good engineer, we can point you in the right direction of some other people. But typically we would defer to them in terms of, you need their signature, and from a liability standpoint and everything like that, it's really best to have the engineer make those kinds of determinations. But I could just tell you, what I can tell you is kind of what's typical. So for a typical size panel, I mean, you might see, and Giovanni can maybe help me here, between 4 and 8, depending on the size of the panel. If it's a typical size panel, would you agree with that?
We get a guideline shown on our ATA certification that gives a suggested distance between the keep nut. But as you correctly say before, it depends from the complete project, because data like flexibility of the material, kind of subtractor, or many other variation independent from our fixing system can influence the result. So the best solution, as Andrew says in advance, is always to have an evaluation from an engineer that after that can sign this decision. Correct.
And that protects everybody. That protects you guys, and that protects us. So
just one more things that could be interesting. We are talking about different material. We want to show you the material we have placed in this demo. This is travertine, granite, HPL, Corian, Marble, Decton. And this is Lexan, just to allow us to see through the fastening system. All the gray facade is made of porcelain glass.
Yeah, and although that that Lexan one is just for demonstration purposes,
Yeah.
I mentioned the sign industry. We've had a lot of people do some interesting things,
Yeah, that
anchoring directly into acrylic or polycarbonate.
perfect. The keep nut perfectly fit in the Lexan. It works very, very good.
Yeah. Got any more questions, John?
Yeah, I wanted to add here, Giovanni was throwing the subject. We have a question here, and maybe we can help you out here as well, Floyd, on the grid systems that you're showing with the panels there. What do you?
Yes, of course. Of course, we can send them all the information about in separate email. Yes, no problem. Will be a pleasure for us to give the information.
Great. I got a nice question here from Justin. Is there a risk of corrosion if installed in an area with lots of humidity or standing water?
No, thanks to the fact that the keep nut is made of stainless steel, and especially the key version is made of AESI 316, that is A4 in other standard, that is the material used for the naval industry. It's absolutely not influenced by the oxidation standing either in the salt water. So absolutely doesn't have any effect on the keep nut.
Yeah, and we didn't show that video, but going back to the sink application, that's one of the things that people really like about it is we've got another video, and you'll see a link to our YouTube channel where we've got a lot of videos, and one of them is showing the drilling on stone. And what they have is the CNC drills the holes, and then the operator just comes in before even removing the material and just inserts right into the wet stone, that's just been drilled. And that's a very time-saving and really convenient process for them, and they don't have to worry about drying out the stone. It eliminated a lot of steps for that particular customer.
Thanks, guys. Here's another a facade or paneling question from Jorge. Can damaged panels be individually removed and easily replaced?
Yeah, it depends from the kind of substructure you are using. The one that we show over there, yes, you can remove one single part panel, because everyone is installed independent from the other. So in this way, you don't have to move the line up or the line down or all the column, but you can work directly on the single panel to change it if you need
it. Any other questions?
I got another one here. This was as far as how many anchors, and G, we can help you out on this directly. But he's just describing, he's got a slab at a certain size and thickness and looking for the keep nuts. I should just add that you can send us this information. We'll give you a general idea on how many to use and what we'd recommend. But like the guy said here, you probably want to incorporate that to whatever panel system you're using and substructure and all that. You guys can add a little bit more to that.
So if you evaluate this question with the table we have shown before about the result, you see that 300 kilos can be handled by only one keep nut. In spite of the fact that this is a slab, we minimum fixed 4. So we have a safety factor of 4. And the question about weight is resolved. What is counting and what this engineer's calculation is the effect of wind, the pressure, or things like that can move force completely different from the weight. So that is once more important if you are making an external facade to have the consultancy of an engineer that is able to evaluate all this possible effect. If you are working instead of for an internal facade like a boiserie, you have no problem at all, because this weight can easily be handled by 4 keep nut.
Yeah, so great. I did just want to point out that we are technically over time. We did schedule this event for 12 o'clock as an ending time. We will keep going as long as there's questions. We'll maybe give a couple more minutes. But for any of you people that are online, obviously, if you have to get to a meeting or whatever, we certainly understand, and we'll again, you'll get the recording of everything. But we'll leave a couple more minutes for some more questions. But I just wanted to give everybody that update, that we'll just keep going as long as kind of questions are flowing.
Here you go, Andrew. I got one for you here. As far as the drill bits go, how long are you seeing these last? And what are the different types again? If you don't mind going over
Right.
that.
So that's a great question. So I'll start off with granite and those kinds of materials. So granite, quartz, natural stone. With the most data I have is really about CNC drilling, and this is still kind of pretty anecdotal. What I'd have to ask a fabricator for a really big favor, which is, can I just set up your CNC machine and just have it drill holes, do nothing but drill holes and count them until it's done? And I'm friendly with a lot of fabricators, but not that friendly. No one's going to do that for me. So if anyone's willing to do that, let me know. But what I can tell you is that I have customers that are buying, thousands of keep nuts a month. So let's say I've a customer in a high production shop might be buying 2,000 keep nuts a month, for instance, and that customer might only order a drill bit from me every, 2 or 3 months. So I've seen really phenomenal life because the conditions are very controlled, where the bit is going up and down at the same rate every time. And if they're drilling lots of quartz and engineered stone, there's even less, some of the production shops are drilling 70% of their production is quartz. And quartz is very easy to drill, and it's the same kind of material. Where it's more of a custom shop and they're doing, they might be doing, like I said, granite on one day, porcelain on another day. If they're doing all sorts of different materials, that's going to affect the life. Porcelain, you want to use the right bits. So again, we've got 2 bits. We've got a granite, 2 for stone materials. We've got a granite and quartz bit and a porcelain and sintered materials bit. So you want to use the right bit for the job. That's going to give you the maximum length. And then there's different types of attachments. So the most common in the US is an attachment called 1/2 gas. We also have reverse thread. That's a specialty bit that some certain manufacturers of machines use reverse thread bits. So we have that as well. And then there's adapters if you need something other than that. And then we also have bits that fit on standard grinders for manual drilling. The one with a 5/8 11 attachment will fit on a hand tool. There's also metric attachments. So if you need was it M11, Giovanni? Is that the standard attachment for in Europe for a hand tool?
We have 1/2 gas or M14 as
M14,
a standard.
excuse me.
M14,
Yeah, so M14 would be the equivalent for a polisher or a grinder. It is possible in natural stone to freehand holes with a grinder. I've seen people do it. I don't recommend it if you're very skilled and have a very steady hand, or you can make some kind of template. Otherwise, we have our KDM drilling machines that accept 5/8 11 drill bits. So then moving on to different materials, we have a drill bit that's it's just a standard, what they call a jobber bit. So if you just have a drill bit that you would see around your house, for drilling wood, etc., we have that. It's the correct size. It's an 11.8 millimeter bit. Those only cost, I forget the exact number, $5 or $10. They're very inexpensive. They'll fit in just standard lithium ion drills if they have a half-inch chuck. And then again, for router bits, for a wood router, you can use almost any size and then program the router to drill the correct size hole. So I think that covers all the possibilities for. The only thing we didn't really talk about is glass. We can produce bits for glass, but we haven't had too many requests for that. The anchor does work in glass. The one thing I will say in terms of countertop material is where we've seen the most usage of glass. And that would be a sea glass material or stone glass, which is a glass kind of material that's made to be a countertop. And then we found our porcelain bits work pretty well for that kind of material. Hopefully that kind of answered your question.
Appreciate that, Andrew.
Yeah.
Got another one here. Thread sizes. What kind of thread sizes are possible with the keep knot?
Oh, that's a great question. I'm surprised we didn't talk about that. So in North America, the most common is 1/4-20. The next most common is 10/24. And certain applications, 10/24 is a better choice. I had somebody called me just yesterday about looking for an HPL application, and they wanted to use standard Z clips, so not like heavy duty Z clips that are used in granite applications. But I asked them what the diameter of the hole is on the clip that already has holes in it, and it would accept a 10/24 perfectly. 10/24 is also going to be most common, probably your best bet for signage applications. We can do special threads. We've had people ask us, we've produced 1032 threads for the furniture industry. We have those in stock right now, I believe. We've had a customer ask us for 832 threads. We can produce it, but that would be a custom order. So if it would require a large quantity. And then metric, we have M4, M5, M6. And then in the stud version, we can do all the way up to M8. Is that correct in the stud version, Giovanni?
The stud version, yes. The maximum one we can produce is M8, but mostly are custom made. So up to M8 we can produce upon the customer request.
Yeah, so the largest thread in standard would be M6. And then if you want the male version, which has a male stud sticking out, which is what I mean by that, we can do that up to an M8. So if you want the thickest, and there's maybe a point to that, because when we do our pull testing in shears, sometimes we're shearing the bolts. So the bolts could be the weak point. So you actually could get some better results by going to an M8.
All right, Andrew. So last question I have here, if anyone wants to drop another question, this would be a good time for it. But last one I have here is just on testing. What are the options for customers as far as if they want to request testing or get testing done?
I'll let you jump in there, Giovanni.
Sorry, I didn't hear you, Andrew.
The question was, what can a customer do if they want to request some testing or any information on any specific surface they're using currently?
There's definitely no problem. We have a laboratory perfectly equipped for this operation. So the customer, we can get just the information on what he would like to test. Then they can send us the samples and we perform the test completely free of charge, and we will return him the test report.
Yeah. And then I mentioned too that we're also doing some third-party laboratory testing for ASTM currently. We have some results. We keep sending material; they keep sending us results. So that's kind of an ongoing project, so we're working on getting that done. So if you're a surface manufacturer out there, I know we have some people in the office in the attendees that are representing surface manufacturers. If you'd be willing to collaborate with us on that, go ahead and please get in contact with us, and so that way we could have some third-party testing that you can use for your customers and for those projects.
Great, thank you, Andrew. I think that about wraps everything up here. If anyone wants to drop a last question, please feel free. But yeah, I do want to thank you, Andrew, Giovanni, Andrea, everyone who attended. Really appreciate it. We know this is a difficult situation in the world right now. We wish we could be in front of you or at a trade show, but hopefully you were able to take away some valuable information during this. I'll leave it to you, Andrew.
Perfect. Yeah, so I just got the contact information flashed up on the screen one more time. Again, I would like to say a really special thanks to Giovanni and the rest of the Special Insert team for joining us and making themselves available after hours to it's probably It's quite late in Italian time right now. What is it, 6 o'clock now?
6 o'clock right now.
Yeah, well,
Yes.
they're being very generous and cutting into their dinner with their family. So very special thank you to them. I also want to thank John for being our MC for today. And I want to thank, lastly, and most importantly, all of you guys for attending. So have a great afternoon, and I hope to hear from everybody soon.
I just want to say thank you to everybody that attend to our webinar. There were many people. We are not very experienced in this kind of operation, but we were very happy to see this huge quantity of followers to our first experience on webinar. And a special thanks to Andrew Morris, John Burke, and all our friends from Chemical Concept. There are not only a very good commercial partner, but also give us a big hand in putting in operation this kind of communication that we are not very used to. Thank you very much to everybody. Thank you.
All right. So long, everyone.
Thank you, guys.
Good luck.